Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0100 indicates a malfunction within the mass airflow MAF sensor circuit. The MAF sensor is crucial for engine performance because it measures the amount of air entering the engine, allowing the powertrain control module PCM to compute the correct air-fuel mixture. Located between the air filter and the intake manifold, the MAF sensor provides real-time data to the PCM, which is essential for optimizing fuel efficiency and engine performance. When there's a failure in this circuit, the PCM identifies the issue via lower than expected output frequency from the sensor. Consequently, it stores DTC P0100, alerting the technician to investigate this component along with related circuits. The mass airflow MAF sensor plays a critical role in engine management. It measures the mass of air entering the engine, allowing the powertrain control module PCM to adjust the fuel injection accordingly. It's located in the intake pathway, right after the air filter, and is essential for maintaining an optimal air-fuel ratio for combustion. The PCM uses the data from the MAF sensor to make real-time adjustments to the engine's operation, ensuring that fuel is burned efficiently. If the MAF sensor circuit malfunctions, the PCM cannot accurately measure the incoming air, leading to poor performance and increased emissions. Therefore, understanding the sensor's location and its impact on vehicle operation is vital for diagnosing the issue. Several factors can lead to a DTC P0100 scenario. One possible cause is an open circuit in the wiring between the MAF sensor and the PCM, which would prevent proper communication between these components. A short to ground can also trigger this code, causing inaccurate readings or complete failure of the sensor. In some instances, the MAF sensor itself may be faulty, which would require replacement to resolve the issue. Other contributing factors could include issues in the powertrain control module, PCM, or related grounding wires. Proper diagnostics can help pinpoint the exact cause of the malfunction, leading to an effective repair. Vehicles experiencing DTC P0100 may exhibit a variety of symptoms. Poor engine performance can be at the forefront, as improper air-fuel mixture affects acceleration and efficiency. Drivers may also notice rough idling, where the engine does not run smoothly, potentially leading to stalling. An illuminated check engine light serves as a warning signal, indicating that the PCM has detected an anomaly in the vehicle's performance systems. In some cases, reduced fuel efficiency might also be noticeable, leading to increased operating costs. Being aware of these symptoms enables timely intervention and helps avoid further vehicle damage. The first step for troubleshooting DTC P0100 involves preparing the vehicle for diagnosis. Start by turning the ignition to the on mode without starting the engine. This action activates the vehicle's electronic systems, including the powertrain control module, PCM, and related sensors. Ensure you wait at least 2 seconds. This allows the MAF sensor and other components to initialize properly. Skipping this step might lead to inaccurate readings, thus prolonging the diagnosis. It sets the groundwork for a systematic inspection of the MAF sensor circuit, ensuring that subsequent tests yield reliable results. The second troubleshooting step focuses on inspecting the external circuit connections associated with the MAF sensor. This involves checking the voltage circuit control 2, VCC2, signal ground 2, SG2, and fuel gauge pulse, FGP wiring. Presence of any open wires or shorts must be determined through careful inspection. Specifically, you should verify that the resistance across these circuits is less than 1 ohm when disconnected. Conducting these checks ensures that the electrical pathways are intact, and allows for proper signal transmission. Any detected abnormalities may necessitate repairs or replacement of the concerned wiring to restore functionality. In this step, attention turns to the MAF, mass airflow sensor itself, along with its integrated intake air temperature IAT sensor. Disconnect the 4P connector from the MAF sensor for a thorough inspection. After confirming that the physical connections are secure and wiring is not damaged, proceed to test the MAF sensor using a known good component. The goal is to assess whether the MAF sensor is functioning properly. Should the issues persist even after replacing the sensor, the focus should shift back to the PCM for further inspection. Accurate diagnosis in this step is crucial, as it directly impacts engine performance and emissions. The final step necessitates an assessment of the powertrain control module, PCM, especially if previous tests yielded normal conditions for other items. First, check the PCM for any faults or irregularities, which can be determined by replacing it with a known good unit to evaluate if the DTC P0100 reappears. If the problem resolves with the new PCM, the original unit requires replacement. Be sure to examine the overall condition of related components that engage with the PCM, such as sensors and wiring, to ensure they are functioning correctly. Assessing the PCM is essential since it is the nerve center for controlling engine performance. After completing all necessary repairs, conducting a comprehensive verification is crucial. This step involves test driving the vehicle to ensure that it operates smoothly without triggering the check engine light. Observe for normal engine performance characteristics, such as smooth acceleration and stable idling. During the test drive, if any DTCs reappear, it indicates that further diagnostic work is necessary. Consistent observation ensures that the previous issues are fully resolved, confirming the reliability of repairs made. Such a thorough validation is essential to maintain customer trust and vehicle safety. Preventive maintenance can help avoid future occurrences of DTC P0100. Regular cleanings of the MAF sensor and IAT sensor can keep them functioning optimally, removing dirt and debris that may affect their performance. Additionally, establishing a routine for inspecting electrical connections and circuit integrity can catch potential issues early before they lead to malfunctions. Furthermore, maintaining clean air filters will ensure that the MAF sensor receives adequate airflow, enhancing engine performance. By being proactive in sensor and electrical maintenance, vehicle owners can prolong the life of these components and minimize repair costs. In summary, DTC P0100 signals a problem within the mass airflow sensor circuit that can significantly impact engine performance if left unresolved. The troubleshooting process involves systematic inspection of the MAF sensor, related wiring, and the PCM to determine the source of the issue. Recognizing symptoms early can lead to more straightforward repairs and less downtime for the vehicle. Implementing preventive maintenance strategies, such as regular cleaning and electrical checks, is highly recommended to avoid encountering this trouble code in the future. Overall, staying diligent in vehicle care will ensure optimum performance and longevity. Please like and subscribe to the channel. See you next time.